Hello students, in this video I'm going to go over how we can solve linear to quadratic systems, or actually any systems of equations, on the graphing calculator. So in the previous video we went over the how to solve this algebraically. So what we're going to do, okay, let's try to use technology to help us arrive at the same conclusions here. So what we can do, okay, in order to use technology, we need to enter this into the graphing calculator. So what we do need to do a little bit of rearranging. So in order for us to enter things into the graphing calculator, we're going to rearrange this by isolating y. So to do that, I'm going to bring everything over that doesn't have a y in it to the other side. I end up with negative 3x squared plus 4x minus 14. Or y is equal to negative 3x squared plus 4x minus 14, all divided by positive 2. And then the second equation, which is this guy over here, that will become y is equal to negative x minus 1. All right, so let's go to our graphing calculator then. So I will go over here. I'm going to press y equals. I'm going to clear whatever I have, and I'm going to enter this. I forgot the equation already. So it's negative 3x squared plus 4x minus 14, negative 3x squared plus 4x minus 14, and it's all divided by 2, right? So don't just press divide by 2, because then that would only be dividing 2 into 14. We need to go to the front of the equation, and I'm going to press second delete to insert the parentheses there. And if you do that, you won't have to retype everything. And over here, the same thing. I'm going to go to the division here. I'm going to press second delete and press open parentheses, and that will push that division symbol over, and I'm just going to insert it. Okay, and I'm going to enter the second equation, which is negative x minus 1, and I'm going to try to graph this on a standard zoom setting first. Usually things are going to appear in a where they intersect on a standard zoom setting, and I can see right now, if you look at this, right, why did we come up with an answer that was no solution, or why did we come up with imaginary roots? Well, that's because the two functions will never intersect, right? I have an upside down parabola, and I have a linear function. The upside down parabola will go on forever in one direction, and so will the linear equation. They will never intersect. Let's take a look at the next example. So similarly, okay, I'm going to do x squared minus x minus y plus 4. I'm going to rearrange this so that everything is over to one side. So this will become y is equal to, I'm going to do this a little quickly, x squared plus x plus 4. Okay? Did I do that right? I did it a little too quickly. So this is supposed to be minus. Okay? So this turns into x squared minus x plus 4. And the bottom equation, that turns into y is equal to positive 3x. All right. So I'm going to do the same thing, x squared minus x plus 4. X squared minus x plus 4. And the second equation was negative 3x. Again, I want to graph this on a standard zoom setting. It's already in a standard zoom setting, but anyway, to get to standard zoom setting, you press zoom and 6. Okay. Wait a second. I mistyped. It should be positive 3x. And here we see that the quadratic equation and the linear equation, they do intersect. So how are we going to use technology to help us with this? So all I got to do is press second, trace, go to intersect, and what we're going to do is, it says first curve there, and if you notice at the very top of the screen there, it tells you which curve you're on. Okay, you're on the quadratic equation. There's a cursor there flashing. What we want to do is we want to move this relatively close to where we think where the intersection happens. And what you do is you're going to press enter once, twice, and then the third time. And the calculator will do its best to approximate where the solution is. Now, understand that the calculator, it's not a human being, right? It's a dumb piece of technology, right? Actually, it's not that dumb, but it's pretty sophisticated. The x-coordinate, it's telling us it's 1.999999. Well, that's because the way in which the calculator is solving the problem is different from the way in which we solved it, okay? It uses a different set of logic. So, however, we understand that the solution is exactly 2, okay? And that the y-coordinate that pairs up with it is exactly 6, okay? And going back to this, that was exactly what we got, 2, 6. And let's take a look at the last one here, okay, where we ended up with 2 solutions. Why do you think we end up with 2 solutions, right? We have a quadratic equation and a linear. Think about the possibility in which a line can pass through a quadratic equation. It can pass through it 0 times, it could be tangent to it, or it can pass through it 2 different times. Hence, we have 2 different solutions. So I'm going to do the same thing. I'm going to rewrite this as y is equal to negative x squared plus 5x all divided by negative 2. And the bottom equation, y is equal to negative x plus 2. So again, I'm going to go back to the graphing calculator. I'm going to clear what I have. So I have negative x squared. Whoops, I'm going to press open parentheses first because I'm going to be dividing this thing, right, by something. Negative x squared, and I forgot the equation already. Negative x squared plus 5x divided by negative 2. Okay, and then the second equation, what was that again? That was negative x plus 2. And now I'm going to graph this. And we can see that it does indeed pass through the quadratic equation in 2 different places. So we press second trace. You go to option number 5, intersect. We're going to move the cursor to where we believe the intersection will happen. And then we're going to press enter 3 times. So the intersection happens at negative 1, 3. We do this again. We press second trace. Go to intersect. Move the cursor over to where we believe the intersection happens, approximately. Press enter 3 times. The intersection happens at 4, negative 2. So, which was exactly what we got. 4, negative 2 and negative 1, 3.